Hi there. So this video is what I'm putting together to help one of my students with an assignment they were given. So for off-season robots they're working on, I tasked them with designing the base of an A-frame to go on our drive from this year with a simple just pure tube and gusset style. 973 is switching to Onshape, and I haven't done it all that much yet, so I'm going to be a little slow. But let's get started. So I'm going to draw the side rails, edge on. Oh, and I should have made those construction geometry. There's no collinear mate, so you got to do coincident here, which is kind of a bummer. Draw that. Make that vertical. I think we had about 1.5 inches ground clearance. That's accurate enough for now. This was 32.5. These guys were 1 inch by 2 inch, and make that all construction geometry. Alright, so we're going to want a centered bearing hole for an FR8 bearing. Make that vertical, and we'll do that, I don't know, 14 inches off the ground for now or something. That's a number that we would come back in and iterate if we were trying to size what the arm's going to be. I've got no idea what that'll be right now. So these are both going to be vertical pieces of 1 by 1. I guess I don't need to draw the one over here. To give us some holes to then attach to an angled piece of 2 by 1 to make the A-frame, and you'll see that coming up. Alright, so as far as I can tell, Onshape doesn't have an angled rectangle tool, so you got to draw those manually, which is kind of a bummer. But with hotkeys and stuff, it's not too bad. Oh, there's no perpendicular hotkey. I guess we can go equal, 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 equal. Then we just got to do 1 perpendicular. Cool. And this is 2 inches. I guess we could have made it equal to this tube here because they're both 2 by 1. I don't know. We'll dimension this 0.5 up or something. And dimension this like 0.1. Just something to get it close. We want the bearing hole centered on the tube, and we will dimension this length because for us at least we like having that be a clean multiple to make the cutting out a pre-drill easier, and then we'll dimension this as a driven dimension. So that's nominally a 1.5 inscribed circle, so that is enough room to fit the bearing in there easily, and you can just see that by the hole obviously. What else do we need to draw in here? So let's give ourselves the holes. So we're going to just put our standard hole pattern on this. And I'm always torn when I'm just doing a couple holes. Do I use linear pattern for that, or do I just manually draw it? I guess I did one more line there than I needed. So here's quick just to draw all 3, but there's definitely somewhere around 3 or 4 holes is where it makes sense to start patterning, I think. We do our pattern a little funky here now. I'm still used to SolidWorks, so you can double click and lose that. Make this midpoint. Need to map some more hotkeys. This will be 0.5. Make a construction. This will be 1.5. And Onshape's not perfect yet, but it does have a lot of good stuff. There are a couple things you kind of got to hack. So if we want to do a linear sketch pattern, and someone please correct me if I'm wrong, as far as I know, we can only push this horizontal like you see here. But if you accept it, which for some reason exits you out of the sketch, you can then come in and delete, oh, not that equal, this horizontal there to let you then move this up. And we can change this to 0.5, make that parallel, and then we'll just iterate this number. And you could use an equation to more intelligently do this, but I'm just going to guess and check. Oh, wow. Got that right the first time. All right, so we got our tubes. I guess we should make that construction geometry. Got our tubes, and we can extrude both the tubes. Oh, you know what, actually? I would like to use this Part Studio to set all of the dimensions, including the width between the two things, the two half A-frames, versus having that be a linear pattern or manually dimensioned later in the assembly and kind of hiding those dimensions apart. I'd like to be able to come in and change this 14, and then the width between this and the other one that you can't see that would be parallel to it, the width between these two guys. So I'm going to change this a little bit. So I'm going to finish this sketch. I'm going to go back above the sketch, and I'm going to insert reference geometry, or plane they call it. I'm going to do that offset from the front plane, that sketch we drew it on, and we'll do that at 3 inches for now. And this is kind of a hack because Onshape doesn't have a full set of assembly mirror tools yet, which is really what you'd want here. So I'm going to edit this sketch. And it's my understanding they're adding those from reading forum post, but we will make do with this for now. So now that sketch should be on that plane. Yeah, cool. We can extrude these guys 1 inch. This guy will be our vertical tube. And what's a bummer is they do have a full set of mirror tools at the Part Studio level, but then it creates them as unique parts, and you'll have 4 parts that are the same in reality that you really want to show up as quantity 4 on the bill of materials, but instead it shows up 4 times, which is really not what you want. So then we'll come in here, and this is where I kind of don't know what I'm doing yet. So I think there's an offset tool. Okay, so 0.125, we'll make that guy a little beefy. And then we'll extrude that. We'll want to do a remove through all. Then we'll do the same thing here. Sketch, offset. We want to change the direction of that offset. Accept it. We'll do 16th wall here. Extrude, remove, through all. Alright, so we got our 2 tubes now. We'll come back and do material properties later once everything is set. So let's draw our gussets. So we're going to have a gusset down here. How do I want to do this? I don't know if it's just me or if it's just not a feature, but you can't mouse over and click like you can in SolidWorks. I'm pretty sure that's just something I have turned off and I got to figure out. So I'll do center rectangle. I don't know, I'll make that. We don't go to the edge because you just want to avoid any possible interference issues from tolerance stack up or any of that kind of thing. Oh, you know what? I didn't want to make that hole. Construction obviously want that hole. So he's back solid. The SolidWorks equivalent of convert entities is, sorry, the Onshape equivalent of SolidWorks convert entities is use. We'll come up and we'll add these guys here while we're here. I guess I actually could have selected all of them and hit U once, and that would have been faster, but still learning. Let's do that. No, it's kind of a funky gusset. I'm not stressing about making optimally clean gussets here. I'm mostly trying to show the SolidWorks workflow, but I definitely wouldn't draw them as kind of ugly as you're seeing them here. Dimension these. Oh, I want to dimension to the center. The other thing that bugs me, and I'm sure it's something you can toggle, is when you dimension to a hole, it gives you that minimum dimension. It doesn't give you the center dimension. Ooh, trimming those breaks it, so let's not do that. We'll just make this construction. Okay, so that gusset down there is good, and we should be able to, in the same feature here, get this upper gusset. Really should have drawn this the other way around the loop. I want that to be vertical. That to be vertical. Coincident. Coincident. Why is this? Oh, there we go, snap 2. Make that 0.3. Then we need to give ourselves a vertical center line to mirror about. And we will mirror that line. We're going to, oh, I guess I don't want to mirror that guy, but too late, I already clicked him. And then give ourselves these holes. Then see if it lets us use that. Cool, it does, but then we need to make it not construction geometry. We'll make that construction geometry, so it's all one part. Now we should be able to extrude both of these, and we want them to be new. And we'll have them be 1/8 inch gussets, pretty beefy. It's cool, we got 2 more parts down here, so we'll rename that. Lower gusset. Oh. Top gusset. Alright, we can hide this for sketch. Ooh, what sketch is showing there? That's weird. I thought I just hid that. No, I hid the plane. I had the sketch. There we go. So now we could take this to an assembly and start assembling anything. Oh, actually, first let's put some fillets in there. Which is F, maybe? Maybe not. Shift F. Oh, and yeah, it doesn't have the power select that SolidWorks does, which is kind of a bummer, but I think overall the pros of using Onshape outweigh the cons and just take a little more time to work on things. I'm not stressing about picking optimal size fillets here. Like, we definitely do a bigger fillet here and there, look a little better, be a little more efficient, but just trying to show the SolidWorks workflow. Onshape workflow. Cool. Alright, so that's done. So because I want to control the spacing of everything from the beginning, I'm going to kind of hack in some features. And what I'm really doing is I'm essentially adding reference axes for the assembly level, because Onshape doesn't actually have assembly planes or axes or any of that yet. I'm sure they're adding it eventually, but for now we're going to hack that in. I don't think this is too much of a hack, and it makes sense. So I'm going to add one there. I'm going to add one there. And what I'm doing is this one up here is going to be the center of both A-frames, and this one here is going to be the center line of the tube. I'll make these small, like 0.1 diameter, so their mass will be kind of negligible, but we could also make sure to set a material that has pretty negligible mass. And I'm using this construction geometry to get these guys horizontal. Okay, so he's located, and then he just needs to be the same size, equal. So let's extrude these, new, 1 inch, and let's name these. So rename this is the center axis, and this is like the tube axis. All right, then I'm going to come in and I'm going to set materials for these. So material set, and now we are going to jump to our assembly. We're going to insert the whole Part Studio, and if you don't click anywhere, it'll put the Part Studio on the origin as you see down there. So we insert that. We're going to fix our first part. Something that SolidWorks does by default. You got to do it manually here. We're going to select everything and group it, which is this guy. So now everything is fully constrained that you see here. And now we're going to start moving our stuff in. So some of this we can get with a linear pattern, and it's not too bad. This isn't the most reflexive way to do it, because if we change the gusset thickness or change the tube thickness, then this will break. But I don't think either of those will change that much. So now we pattern it the tube thickness plus the gusset thickness, and that'll get us that. And these are properly modeled. So if we open up the bill of materials, you can see that we have quantity 2 of these 2 gussets versus separate line items, which is nice. I'm really excited about using bill of materials a lot more, since Onshape opens really cleanly on the phone, so we can have a lot more kids in shop on the robot on their phone or tablet, really looking at assemblies. All right, so the next step is we're going to take advantage of the fact that these parts are symmetrical and mirror about this right plane here by revolving around that. And that's a little hacky. Hopefully by season they just have these features implemented. But if not, we can do this. Set that to 180. Cool. That worked. And now we're going to do that same thing again around that center axis. And really, I think the takeaway here is those parts that we're adding in the Part Studio that are redundant, that we, I forgot if we excluded them from the BOM or not. I'll have to go back and check that. Those are assembly reference axes. So now we can see the origin is there. So we have an origin that is on the floor of the robot, which is something that I really like for top level assemblies like this, and is centered on the is it the medial plane and then the anterior posterior plane? I might have those names wrong. And if we come in and look at our bill of materials, okay, cool. So we did not exclude those axes. So I'll go and show that, and you can see proper quantities for all these. And if we open up the top level robot bill of materials, once this is put in something, we'll be able to see how many gussets we need to make. So cool trick, we can come in and select both of these at once, go to properties, come down and hit exclude from bill of materials. And we could fudge the mass too, but their mass is so small that it's really not a big deal. And now we can see that they are not in the bill of materials. So we don't have a library yet to do bearings or any of that setup. We do have a couple fun parts in though, so I'll drop in one just to show the shaft. So measure that, it's 8.25. We're going to add another 1/8 inch, so 8.375, because we know we're going to have those bearing flanges. And then we'll round that up to like 8.39. Let's call it 8.4 to account for tolerance stack up. So now we're going to come in into our very minimal library in our VEX shaft. We have a pretty cool one. So we're going to do an 8.4 inch functional length. It's going to be a 1/2 inch shaft. It's going to be tube axle. We're going to have snap ring ends. We're going to generate that. Put that there. Now, since I don't actually know Onshape all that well yet, I don't know the best way to make this symmetrical in there. So we can start by doing not a fasten to mate. We want to do a cylindrical, I think. And that should let us move this left to right. Yeah. So I'll just leave this there for now. And my fantasy is, this is mated by its primary plane. So that's how we do almost everything in SolidWorks. So if we come in and change dimensions and stuff, that we don't have to remate anything. I don't like mating by, like doing the dimension from here to there, that sort of thing. And it wouldn't be the end of the world to do so. So cool. Hopefully that was helpful. Showed you, some of the cool things you can do with Onshape. And thanks for watching.